everyone.
Hey, there he is.
Hey, hello. So, hello, Alex. Hello, Tom.
Hey, hey.
Hello, Anoop. So today I want to go a little bit about the basic claims of Lexon, about how it is read and how it is written. The reading and writing part are interconnected, and the claim that Lexon should be readable actually without any learning curve at all developed throughout the development. And it was actually pushed for by open source legend Brian Fox, who rightly argued that contracts are more often read than written, which is actually a logic that we know from programming, where that's true for programs too. People who have to maintain it, people who have to read it, are going to spend more time when the program is actually used than the person writing it. And it is, in a sense, the same for what the purpose of digital contracts are. And so today I want to explore with you guys whether that goal is actually achieved and just read Lexon contracts that we have at this point, but also go to the part where it's about writing Lexon contracts. And it was, for me, the big threshold to cross, basically, to optimize readability, because I felt writing might then become forbiddingly hard. However, it turned out that's not the case. And it's one of the big discoveries, to me at least, of the whole project. And meanwhile, we have with wonderful contributions from Carla and a student of Carla's from SMU, who basically just took the documentation. They didn't ask me, they didn't get any education from me, except for the documents as I wrote them, and gave it a try, right? And then got my feedback for sure. But it was very encouraging to see that actually, yes, you can just sit down and give it a try. And we will look at different examples, but also at a structure of what path of thinking makes sense to actually write a Lexon digital contract. And we even go to, and eventually we go to the point where it's about how do we translate an existing contract, maybe even an existing law, into Lexon. And also that is possible. There is it doesn't work like going in and just translating line by line, because Lexon has a very clear structure. And I will also introduce that structure that the Lexon documents have. It is actually a simple structure, but that is something one has to understand to be able to write it. And it's going to be interesting to see. Hopefully you will see that you do not have to understand the structure to read the contracts, because a reader is prepared to go by the structure document proposes. So I would like to go through a presentation now, and then also do some live coding to basically, yeah, give you a better feel about how it can actually feel writing Lexon online. And the bracket of this is going to be some general thoughts on what Lexon is, what it can help commerce to become. And then I would also, in the end, pitch what the platform is that we're working on to enable collaboration, enable the online editing that I will also show, to support writing and reading and sharing and even monetizing Lexon contracts. So I'll share my screen and start with the presentation, if I can find it. This looks good. So in the end, and I will talk a little bit more about what the Lexon Hub is. Right now, we will mainly look at reading, then also the document structure, do a little bit of live coding, and then translating existing contracts. So this is a example that I have given many times, and it's a very straightforward example. It's basically a building block. It's a very simple escrow. And the challenge, of course, is just like, okay, so if you're confronted with this, can you just read it, right? And I would say you could. There is a tag that is called Lex, which we have discussed a lot about, but we left it in because we feel that when Lexon code is embedded in normal contracts, it will be a good thing to have a clear mark where the automation starts. So that's the first tag, Lex escrow, right? It's a headline, obviously, right? Then you see some definitions, which is something that is hopefully pretty much self-explanatory, which is saying, okay, there are those subjects, those actors here called payer, payee, agent, and there's a purchase price and there's a fee, and those are amounts. Well, it doesn't say as much, but it's also not confusing. It's not ambiguous. Yes, it's not yet telling us who the persons are, who the amounts are. And this points to something where Lexon is a little bit more than just a contract, because really it's a contract template that we're talking about here. But the claim in itself is Lexon readable. Well, I guess you can read this stuff, right? And then we come to something that we call the recital, which is basically setting this whole contract up, where we'll say everything that happens first is listed first here. So the payer pays the purchase price and the fee into escrow, appoints the payee, appoints the agent, and also fixes the fee. So what's happening here on the legal side, right? We're saying that a payer pays something into escrow, right? And we're also, whatever the purchase price and the fee are going to be, that's what the payer is paying into escrow. So that is what basically happens at the beginning of this contract. And then the payer, which is odd at first sight, right? The payer also appoints the payee and the agent. That's because it's a simple example. We're just saying, okay, so the payer sets everything up here. If the payee doesn't like it, they just not gonna enter into this contract. They're just not gonna use this, so to say, don't accept this. The payer also appoints the agent. The agent is basically the oracle in this case, who is going to feed in the information from the outside world into this blockchain smart contract if it runs on a blockchain. And the fee is also fixed. That plays a role later. Then we have two clauses. And those clauses basically define what could happen. Either there's a payout or there's a payback. And the first clause, the payout, is actually triggered by the agent. And only the agent can trigger this clause. We've discussed a lot with lawyers and about the significance of the word may. Does may really include everybody else? Like if we write the agent may and then follows a sentence, does that also mean the payer may not? Or does it at least may, if it's not written anywhere else, it's not going to be enabling the payee to be the one who's triggering that clause, right? And it turns out in the end, yes, lawyers are confirming that this is what's actually happening. If you write it this way, then that is what's happening here. And on the programming side, it's pretty clear. It's just an if clause, and that is going to make sure that whoever is calling this function has to be the agent for the rest to execute, right? And the rest of it is also pretty plain English. It's nothing that is arcane or intransparent. What you can discuss about and what might actually change is the end afterwards, because the concatenation with a may might not be strong enough yet for the legal side. It's not a programming side issue at all, but it's something that we have been discussing with lawyers, and it's going to remain a focus of our fine tuning to find out what is the simplest possible language that is unambiguous and still reading very normal, also for non-lawyers to be able to understand, and for programmers to be able to understand, that we can use here. So this hopefully, that's my standard start, and it's hopefully convincing enough that actually, yes, you can read this. And for a programmer, it's at this point also pretty clear how this is translated. And we will look at that later, actually. So taking a step back, what Lexon is in some way a claim that artificial intelligence is not going to be able to read normal contracts and translate them to perfectly analyzable code yet for some time. And Lexon defines a meeting ground in the middle, a language that both human beings and computers can read. That's called a controlled language, and that is something as a concept that's around for quite some time. Even longer is the concept of using English normal words to make programs more readable, and that started in the 1955 with Grace Hopper. And a friend of mine even told me today, "Oh, great, you reinvented COBOL." Yeah, because COBOL also, a very long-living programming language, had a very strong push in it. It was actually created using this language here that we see on screen right now. And it had the same spirit in it by Grace Hopper to be something that you can read as well as possible as a programmer. However, where Lexon is going further is it retains much more of human language. So it is perfectly normally readable without any computer science knowledge, where COBOL clearly has as subject bits and bytes and files and data. That contracts or even law should be programmable is a very old thought, and it's actually dating back to the document that is considered to be the start of computer science, where Leibniz, who was actually he was a professor of law and also a practitioner in law. He would take part in law reform of the state that he lived in. And he proposed that because they didn't even at that point had the difference clear between software and hardware, but somehow you should be able to program simple laws. And the law on the right-hand side here is actually what he proposed should be programmable. And he also, in this document that he wrote that's considered the start of computer sciences, he also had examples from geometry and philosophy. But the very first example he gave was actually this very law, which is an old Roman law from 161 after Christ. But this is where it started. So it's not really a surprise that contracts and law and programming have very strong commonalities. The areas that Lexon could affect are really many. And that becomes apparent after some thinking about what it means that all of a sudden everybody is going to be able to understand programs, and those programs might have the superpower blockchain so that they can actually move money. The quantum leap that this will mean for a lot of areas are being tutored for a while now by the blockchain, but there are basic building blocks that are coming together now, where Lexon will be one of them, that will make it possible to actually completely revolutionize the entirety of commerce and probably also of governance. What happens is that there's a weird collapse happening, right, between what law is and what software is. And that has a consequence of a massive speed up and also of a massive cost reduction. And that's very welcome. We won't go deeper into this, but just a number of things that it means for law. First of all, you can test law all of a sudden. You can use the tools that we use as a programmers use all of a sudden for testing laws and contracts. You can make algorithms transparent. In the US, there are mandatory sentences that come out of black boxes that judges are forced to apply in their rulings. And now this will allow lawmakers to decide about what should be in those black boxes and make them transparent. There are a lot of questions, for example, with self-driving cars, the same with any type of access to anything that you own that is now in part remote controlled, where the source that actually governs access and governs decisions could now be made in an open process, including lawmakers. And at some point, we will also have to talk about ethics of machines, and the robotic laws, as Asimov articulated them, should probably be articulated at some point in time in Lexon. That's a little bit ahead, but we're talking what is going to be possible through all this now. I think that the most interesting prospect of all this is going to be that we're going to have some kind of new artificial intelligence that will emerge on the blockchain using smart contracts and even using digital contracts written in Lexon that are human readable, where you have as payload not only money and titles, but you can have words that are actually having legal meaning. And that is a payload that is actually sometimes even more powerful than moving assets. So let's go back to reading. Let's go back to finding out how well Lexon is readable. And let's, after we have looked at this escrow example, look at a little bit more involved example that has more moving parts, so to say. And what we can see here already, what we've talked about, is a very clear compartmentalization of this entire text into the head, definitions, a recital sentence, and then the clauses. And if we look at a new example here, then we have the same structure again, but we can also see that there is an additional part here where we really go to the border of what intuition can understand. However, what this really means here is it is defining something of a subcontract within the contract, which is typical for smart contracts, which often can be more of a vending machine that gives individual contracts to riders on the public transport, for example. So they are a system that creates individual agreements. And we have a similar situation here where we have an overarching legal document, which is the will of someone, and then the individual subcontracts, so to say, that go to each individual hair. And if we look at this, it's a very, very simple, very straightforward algorithm almost, how an inheritance should be distributed among hairs. But the part that is now marked here in yellow is kind of the subcontract per hair. That's also why it's called contracts per hair. And we have multiple hairs here. We have multiple shares, the one per hair, obviously. And what happens with all these individual subcontracts is always the same, right? So it's defined as one chunk in the bottom here, marked yellow. We again have the same structure as before. We have the head, then we have the definitions, and then we have the recital, and then we have one clause in the terms, in the general terms of this will. And then this is repeated also in those individual contracts per hair. And in both parts, we have the definitions, then we have the recital, which is the first thing that happens within the contract. And then we have the clauses that always start with defining what happens when they are triggered. All this can also be used to an even more complex type of agreement. And in this case, it's the agreement of a DAO, or the agreement of a company that is a DAO. The charter of a company, basically, that is Lexonified, or that is expressed as a smart contract, however you want. And this goes, this is just a subset of it. It has multiple pages. But again, the question is, how readable is this? How clear is this as a charter? Is this clear enough that you could file it as the bylaws of a company to the filing office? And if we look at this, and if we go into this a little bit deeper, what we can see is, again, we have, this time we don't have Lex, we have charter as a synonym for Lex. And then we have, again, we have the headline of terms, and we have a couple of definitions. The founder is defined, the director, then the total shares, the application fee, and more specific stuff like the member's initial number of shares, then the founder's initial number of shares, which are going to be important to process the individual steps of this charter. And then we have the recital, which is in the middle here, where it reads, membership is established for the founder with the founder's initial number of shares. The founder fixes the application fee and also fixes the member's initial number of shares. The founder is declared director. So that's what you have to set in the beginning. I guess this reads almost a little bit more than like natural language than the examples we had before, but it's you see the same pattern. You see the same type of uh, overall structure that emanates these documents. Then you have clauses here: set fee and applicant share. The director may set the application fee and set the number of application shares. So this is basically the director manipulating the settings of the corporation, right? Because that is going to be used in each individual application later. Then you have the clause to apply. A person may pay a fee into escrow to make an application for themselves with this fee. It's left open what the fee is at this point. And then you again have this kind of subcontract, as we talked about before, where you have per application, the following holds. And again, you have the definitions, you have a recital, and you have the clauses. And I would like to just read through them very quickly to make clear how this keeps recurring within the same structure, building up something like an object structure really, but at the same time being the legally complete and acceptable definition of the bylaws of a company. So applicant is a person, fee is an amount, the applicant pays a fee into escrow. Clear. Clause reject. The director may return the fee to the applicant and terminate the application. It's pretty clear. Clause accept. The director may, if the fee equals the application fee, so now we have a test here, and everybody who knows a smart contract understands why this is this way. Because obviously, if you just trigger a smart contract, you can send anything to it, right? So this is why this is written with that knowledge. Obviously, the director is now matching whether the fee that has been actually sent is matching the application fee. And the applicant is not a member. Yeah, that's very programmatory, but it's also legally correct. Then establish membership for the applicant with a member's initial number of shares, after which the application is complete. And that actually means that this subcontract ends, so to say, this part of the smart contract. Then clause list of applications, the director may see the list of all pending applications. Clear enough. Now we have the contracts per membership. And that is another, as a programmer, you understand that's another subclass. That's another class in this whole. And what you can see here again is the same structure. You have definitions, you have a recital, and then you have clauses, what can happen. And we won't go through this line by line here now, but it is going to be the same type of rhythm and that this breathes, and it's the same type of readability that is on the legal side, sufficiently clear without having to understand programming, what this means to be useful as the official bylaws laws of a company, and at the same time be the program that the DAO runs. So now I would like to skip to something yet more exciting, I would say, that is how to Lexonify law. And as an example, I'm going to use something that has been in the works by Carla Reyes, an assistant professor at SMU, who's part of a lot of very interesting initiatives. And among other stuff, she's a advisor to the reform committee of the United States Unified Commercial Code, which it means basically the commercial law that all states can agree on. And there's one form that is basically how you secure your rights to a collateral as a bank if somebody comes to you and offers a collateral for a loan. This form is famously error prone, and it has lost banks billions because of making filing mistakes. Because if there's a mistake and the form is not valid, then if there's a liquidation of a big company, a bank might see nothing, and somebody else might get priority on the same collateral. The financing statement has been restated, or how this financing statement should work has been restated by Carla as a Lexon contract, as a Lexon digital contract. And I will not go into all of the different aspects here. she's going to publish a paper about it that's going to come out soon. But I just want to give you an impression of how this looks, right? Because this is now law, US code that is expressed as Lexon code. And I didn't actually see that coming because I didn't understand how procedural law is at sometimes. I was very focused developing Lexon on contracts. But this is something that is very possible. And we're working on this now. We're talking with different states actually who are interested to taking this up because there's a reform of the UCC happening right now. And of course, they want to be blockchain friendly in the reformed version. It's just the question to what degree will they be. So at this point, this code will not land on any books. It will not become part of the UCC code itself, although in the future it could. But at least what hopefully we will achieve is that states will not be barred from using this as implementation of the law as it will be after the reform, and achieving better results, hopefully, than using the PDF form. So what you see here, again, are the definitions, right? There's the head, and then there are a lot of definitions, and they're very unspectacular. It's just basically setting the names that are going to be used later in the code. And the code, as you see, is very simple. Like the clauses that you can see are very simple. And the individual sentences are very short, and it's not anything particularly convoluted that's happening here. It's just a number of data points that have to be collected, so to say. It's a sequence that has to be obeyed, but it all starts at the top with the filer fixing the debtor, the secured party, and the collateral. There's a confusing specialty about this form, which is basically that the bank is having kind of superpowers because they basically they enter this form, and they can also declare they declare the default, and because of how the law works, that is basically giving them all rights out of this statement to then take the collateral, and not one like there's no court process involved or anything. That's the point of this whole filing. But basically what is happening here in the beginning is you're setting up the data again. The first four clauses are all about the filing office having to enter certain types of data. And then there are clauses here that are basically saying, okay, so as something we added, we invented on top of this is the secured party may pay a reminder fee, because that's one of the ways that banks have lost millions, is that they forget to prolong this form. And this version here gives the filing office the possibility to have additional income by collecting a reminder fee, and then for that reminder fee, reminding the secured party that they should prolong the statement. But then another optional element, of course, here is that this clause makes it possible that for the debtor to pay in assets from a cryptocurrency, for example, to secure those. And it's very simple, right? It's just one sentence. And then this is the heart of it, taking possession, where in a very brutal form, really, the bank can take over just by declaring it. But this is not something we invented for this contract to be simple. It's just like this works, right? And then we have housekeeping, so to say. We have a continuation, how that is filed for, that this form is continued for another 5 years, and the statement continues for another 5 years. And then we also have that the escrow is being released if there's any escrow in the process of the termination of it all. And again, what I want to look at here is really just like, okay, so is this readable? Is this something that if you would not think about this as a program, well, you would maybe be confused about why it's termed the way it is, because you can see there's something going on there, right? But otherwise, it's pretty clear English that anybody can read without having to understand anything about programming. And that is the very point here. So now I would like to come to the next part, and that is about writing Lexon. So I will switch over now to some live coding, just to give you a little bit of a feel how this looks. All right, here we go. So this is a live editor where you can try your hand at Lexon code. And I will now just go through 5 different variations of very simple code, just to give a little bit of an impression how that works. Again, the first keyword is always Lex, and a very the most simple example that exists probably for smart contracts on the blockchain is that you want to burn an amount of cryptocurrency. That's actually something that happens pretty often in the gamified world of blockchains, usually to transfer value from one chain to another and establish scarcity on this new chain, so that you can have tokens on the new chain only if you burn assets on the old chain. Regardless, it's just something that is a very simple contract, and is basically just going to mean read the pair pays an amount into escrow, and if there's nothing else to the contract, well, then there's just no way to get the money back out. So that's why it's called burn. And what you can see here on the right-hand side is the solidity that's happening. And there's also a version of Sophia, which is the very beautiful language for a different blockchain. It's called Eternity. And that's here to make the point that actually we can compile to different targets. All this is running as WASM in the browser, because this is all the compiler is programmed in Rust. This version of the compiler is programmed in Rust, and it's translated to WASM, so it's running in the browser itself. That's why it's nice and fast. And now the next, and again, you see like this is the head, this is the definitions, and this is the recital, and this is all there is, right? So now we're going to make a more interesting contract, just one step more complex, and we call it show me the money. And that is the payer pays an amount into escrow. And then we have a clause where where the payer may return the money to escrow payer, and that doesn't work because the payer may. I apologize. There's some typo here. I'll fix it later. But this is basically a very simple way to just say, okay, I have paid in the money and now I'm taking it back out. Not sure why it doesn't work, but we just continue. So then we have something that's a little more like an escrow, where we say, okay, the payer, and then there's a payee. The payer pays an amount into escrow, and then there's a payout. Still not working. Let me check why it's not. Payment. Stuck in some form. Let me reload. Looks better. Not sure what happened. maybe some invisible character. That happens sometimes, something we will have to improve. So this is a very simple escrow that just has the interesting propensity that the payer can say, okay, I can pay the money in, and it can only pay forward to the payee. And if the payee doesn't do what was promised, then, well, the payer can decide to just leave the money there, but they can never take it back. That's usually not often explored, but it's a typical blockchain logic thing. So then you can add payback. You could also have the clause that the payee may pay it back to the payer. So that's more kind of a friendly escrow. And all the time it's also running in Sophia here. So that this is here and Solidity and Sophia would usually in the end, that would all be under the hood, right? It really serves us well for a demonstration to make one see that there's really some transformation happening here behind the scenes all the time. But in the end, you just want to click deploy to blockchain. You want to fill in, there are forms popping up, and fill in the names or at least the addresses, the Ethereum addresses for the payer and the payee and so on, and then can deploy it on the blockchain. But that's not the focus today. And I just want to give you the full escrow example that we had earlier. We just said, okay, we have the agent, and then we have the fee, is an amount into escrow. Oh, yeah, points the payee, points the agent, and again, we just say it's a simple example, so we let the payer set everything up, and also fixes the fee. And then we have payout, and that's done by the agent here in this case, and then that's also done by the agent here. And all of these intermediary steps are actually valid, possible contracts for certain occasions, right? And Solidity is happening on the right-hand side all the time. And the full-blown example, like we witnessed in the beginning, was the agent may pay from escrow fee to themselves, and afterwards pay the remainder of the escrow to the payee. And payback is actually established as like this. You just have to change here. We can change pay to return. The Solidity is not going to change, but it reads nicer. So this was basically meant to give you a feeling for how dynamic writing can be and how you can really get used to what's possible in Lexon, what's not. The big fear, anxiety, the big question was whether by making Lexon as readable as it is now, legal prose is very formulaic, because lawyers and legal professionals like to use language that has a that is coined and looks and sounds a little bit old-fashioned, because those terms mean special things. And by them sounding old-fashioned, that's almost like a marker for them to be exactly what has developed as meaning in law. And that shows that law, in an attempt to be less ambiguous, already had migrated in a way into a direction where there is this attempt to make it less ambiguous than normal language. And to be able to navigate that, of course, you have to know the rules. So lawyers are accustomed to this kind of a controlled language like we are using here. And that should actually then turn out to not be so hard to learn for legal professionals. There's still the argument to be made that it's not clear that lawyers actually are open to using this. We're working a lot with students and universities now, because the next generation might be more open to this. But that's a matter of adoption. The question is, can it actually work? And as an example here, I mean, usually in live presentations, I like to ask the question, what do I have to change now when the payout clause to make it the payback clause? And it's so simple that people sometimes don't dare to guess that it's just changing this letter really and giving it a new name. You just copy paste it from payout. And that the point here is how simple it is to give the whole thing a different meaning. And how simple it is to say, okay, if it's just a payout, then maybe there's no fee for the agent, or vice versa. If it's a payback, then there's no fee for the agent. The agent may pay the escrow, however. And the point is just how natural this is. And there's a very interesting point here that I think is very is going to be very controversial for a long time. But what I saw is that when people watch me writing this, and at one time I wrote this wrong, and the person who I was showing this to was just witnessing me writing Lexon for the first minute, and corrected me and said, well, that's probably a typo. You probably wanted to write an amount. And that's crazy because that person had no idea about Lexon at all. They caught a programming error in a language they had never seen, so to say. And they were even able to guess correctly what the correct word would be. And that's not really what would happen in Solidity, right? In Solidity, I would have made the mistake, well, actually you can see it here, if I write person, then it comes out as address payable fee, and what actually should have happened is an amount, uint fee, right? And that's just like uint is, as a programmer, that's exactly what you have to look up about a language you haven't written in for a couple of months. What was that normal integer without a sign? What is called the unsigned integer, or uint, or uint 256? And that's exactly the point that even as a programmer, you have to relearn all the time. Now, it's not just about having smarter names. Of course, Solidity could just have used amount instead of uint. They didn't, but that's not actually the point. The point is that in Lexon, if somebody doesn't read right, if somebody looks like a typo and doesn't sound right grammatically, it's probably a bug. And that allows you, it seems, to think about the correctness of programs with a different part of your brain that is hugely complex and incredibly fast. And that is not usually how you are debugging normal programs. I guess we programmers develop some weird parts of our brains and to be able to parse this fast, but it's not the same. So I wonder at this point if possibly Lexon might turn out to not only be for non-programmers, but I don't have to go there. It's just something I'll throw out there because I think it's an interesting possibility that we will see that Lexon is also for programmers. So let me go back to my presentation and let's look at some more aspects of writing Lexon. So next up is an example for a license by Florian Edelberger. And this is basically an exercise, and the question here is, and I'll just do it fast, how do I get from a normal language to a Lexonified contract? And the fact is that you do have to, it doesn't work that you just go, like this looks like, well, you should be able to do it article by article, right? And ideally, you would just parse it and it's Lexon and it's good, right? And the future, when Lexon's not needed anymore, would be that a program that can actually really understand natural language can just use this as is and do exactly the same like Lexon can do. As I said in the beginning, Lexon is the premise that this is not actually around the corner because of what I understand from the lifelong observing of AI, what AI can do, what it can't do. And here are the steps, basically, how you translate a normal paper contract into a Lexonified contract. And it's simple. I mean, you identify the nouns, basically, who's acting. And it really helps to go through it with markers, because those will appear in your definitions, obviously, right? They might already be in the definitions of the contract. Then you identify the actions, like what is paid, what is transferred, just to find clarity, right? And again, you can do it with a marker, and it's helping. Then you look at the conditions, the ifs. What is happening in what case? And that is the first kind of sorting out what actually happens in the contract on the semantic level, right? Then you identify those subcontracts that I had talked about in the beginning. Like, is this paper contract maybe also, usually it won't probably, but are there sub-agreements being formed in this paper contract? And then what you do is you identify the happy part, like leave out all the exceptions, leave out all the fringe cases, just go through, okay, what is the actual intention, and code that first. And then what you do, you go by the actual structure that I have introduced. That means you build the definitions, you list out the definitions, then you write the recital, that is the stuff that should happen in the beginning in the terms, and then you write the clauses, right? After you're done with the happy path, then you add, bit by bit, you add the exceptions. And I won't go too deep into this, but it's just like, this is the marking, so to say. What are the nouns here? What is the license, the sub-license? Who are the actors, the licensor, the licensee, the sub-licensee in this case. And this is then already the results, and just browsing quickly through it. It's more verbose than the original paper contract in this case. It's not always the case, but it's the case here. And you see this, it's completely expected. Like, you see those, you meet those subjects, those nouns again, and the definitions. You see a recital here. The licensor appoints the arbiter, fixes the licensing fee, and fixes the breach fee. Not unexpected at all, just in a different order. And now you have those subcontracts in this case, which are called license in this case. And again, you have the definitions, the nouns here, nothing unexpected at all. And then you have the clauses, and they are what actually should happen. And this is a little bit involved here. It's about, okay, this, you lose the sub-license if you fail to publish a comment about it, and then you get a notification, and if you don't rectify it after 24 hours, you get canceled. So that's the actual payload of the contract. But again, the individual clauses are simple, and they're very readable. Yeah, it's not the time right now to go deeper into this. I just wanted to show you what it amounts to in the end when it's Lexonified. How the structure is actually different. It has to be different. The article 1, 2, 3, 4, 5 of the original is not actually usable if you translate it to Lexon. Arguably, the Lexon version is more readable. Even though it has a weirder structure, it's arguably clearer in what has actually happened within the contract. So in closing, I want to point to a work by Menes and Arsmont from SMU, a student of Carla Ray's. And this is work that she's going to publish a paper about, and I won't go too deep into it, just the very first bite of it, so to say. This is the complement, so to say, of the will that we looked at in the very beginning. This is the law in the US, what happens if somebody dies and does not leave a will. And in my view, it's just a beautiful reprise on what Leibniz wanted in the beginning, because it's a piece of law that's very procedural. And having this Lexonified would actually really help, because usually one of the descendants is going to be appointed to be the person to execute this. And I'm sure there were a lot of honest, very honest mistakes happening all the time because it's so convoluted. And it basically defines what should happen with the money. And with a estate, and how it is shared among spouse and other relatives. And if you look through this, yes, it's obviously kind of a if else or a case switch for programmers, right? You would as a programmer, you would immediately you would write it like this, because these are sub cases, but in the law at least you have A, B instead of 1, 2, 3, 4, in the beginning of the paragraphs. And then here I marked what the actual conditions are. So what is marked highlighted here in blue are the parts that would, as a programmer, you would put in the if clause as the condition. And the payload is all the rest, so to say, what happens. And if you would think as a programmer and how you would have to program it in Lexon right now, but we will change this in the future, is that you would flip it, right? And in programming, the conditions come first. And then what should happen if that condition is fulfilled? So if I go back to the slide before, here you can see how the law is crafted, which is like, it says first what should happen, and then it names the condition. And the next version of Lexon will actually make this possible, because to be closer to how laws are obviously actually crafted, right? But right now in Lexon 0.2, you would have to write it like this. You would have to flip it, put the conditions first, and then what should happen after. And then there's this another element here. That's the next chapter, so to say. What happens if there's no surviving spouse? And I marked here what is interesting, where actually the law does not have a good way to make nested if-else conditions. And everything I marked here red is actually else conditions. They kind of re-narrating what had been in the if clauses, in the light blue clauses before, or even on the same page here. And it tells you how there might be a contribution coming from programming that even in lawmaking, people will benefit from, because this is, of course, a source of error in the actual practice of lawmaking right now. And I'm sure they spend a lot of time to make sure that whenever they repeat stuff just to basically say else, that they repeat it correctly. But it's very easy, as we know as programmers, to still have a case falling through the cracks, and then that creates a loophole, right? So in closing, I want to say collaboration is incredibly important. That is why we're creating the lab, exactly to have this kind of discussions and on a platform that will allow you to share your code, to have others commenting on the code, and to come to bug-free, error-free law or contracts or regulations in the future. And the Lexon Hub is basically going to be a place that, like GitHub is for open source, should be the place where code like this, that is both human readable, but also at the same time programs, will be shared and discussed and maybe even monetized. And the individual elements of the hub, I want to go through very quickly here now within a minute. One of them is auto completion, so that while you're typing, from the wealth of code that the hub is going to be able to explore, you will be able to get useful auto completions to make sure that actually what you are putting in there is going to be compilable just from the get-go. And another thing that everybody knows from Word track changes is that you can see from version to version what you have extended, what you have upgraded from one step to another of a program. So others can see what you have changed in the template that you are proposing for a certain contract. Another element is that you can have metrics for success of open source projects, so to say, that are running on this platform. And you will even be able to build a brand, so that if you are contributing templates that others are using, you can start, because of your digital signature under those templates, to build a name for writing these kind of contracts. And that can even be used for micropayments, so that, because if you run it on blockchain, what you can build into the contract and what cannot be extracted without breaking the brand seal, so to say, are kind of not even micropayment, but nano payment triggers that can be built into the contract, and that are basically a payment for using your brand's contracts with possibly a warranty staked on it. In the end, that's also a possible on-ramp for projects to become a tokenized project. They wouldn't be able to tokenize it on this platform, but they would be able to build a following to give out tokens that at this point cannot be any type of listed as an exchange or redeemable for money or anything, but they can start awarding tokens for people that might become anything later, just as a bookkeeping exercise, so to say, as a preparation for later going off platform and then doing something with them. What we will also propose for this platform is in collaboration with a leading provider of a stable coin that is on Ethereum right now, a way to monetize these smart contracts without having the volatility of the cryptocurrencies that in the moment only go up. That's awesome, but at some point might go back down. And that's it. Thanks a lot for your patience. Thanks a lot for staying with me while running over. And I'm here. I'm happy to answer any questions.